Hello again, welcome back to the channel. Today's video we're going to keep talking about parabolas. We're going to continue off of yesterday's lesson. This is actually the second part of lesson 8.3 in our chapter about quadratic equations and parabolas. Yesterday what we talked about was how to use the quadratic equation to calculate the axis of symmetry and then find the vertex. And today we're going to keep using those skills, even though the words in the vocabulary is going to be a little bit different. So today we're going to have some questions that ask you, A, does this function, does this equation have a maximum or a minimum? And if so, it'll always have one or the other. Find the actual maximum or minimum value. And it's really just an extension of what we did yesterday. None of the skills that we talk about today are going to be brand new. This is just going to be building off of what we did yesterday. So first of all, I did a couple examples right here. Oh, my green marker is biting the dust. Let me switch to purple. Here's a couple examples. What does a parabola look like when it has a maximum, right? So a maximum, in case you're unfamiliar, the word maximum is the highest something will ever get. It's not just a word that you use in math. You use the word maximum quite a bit just in real life. You've probably heard it before. The maximum is the highest that something will ever get. So in this case, when we're talking about a parabola, the maximum is right here. The highest point, the vertex, right? Remember that from yesterday. The highest point that the graph ever reaches. So parabolas that open down have a maximum. Right? They have a highest point, and then everything else on the graph is below that point. These will never have a minimum. A minimum would be on this one, right? A minimum is the lowest point the graph ever touches. This doesn't have a minimum because it goes down, 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 down to infinity and beyond, right? This keeps going down forever and ever. So there is no minimum. It will only have one or the other. If it opens down, it's going to have a maximum. It's going to have a high point, kind of like the top of the St. Louis Arch, if you've ever ridden a little elevator thing to take you to the top of the St. Louis Arch. It's kind of like reaching the highest point. This, if it opens up, like this, opens up, it will have a minimum. The minimum is the lowest value that the graph ever reaches. Right? So that is what a maximum and a minimum are. It's basically the same thing as the vertex, right? It is the vertex, the highest point or the lowest point. It's that point right in the middle on the axis of symmetry at the exact point where it reaches the very bottom of the hill here, bottom of the well, or at the very top of the arch, right? Now, how can you tell just by looking at an equation if it's going to have a maximum or a minimum? Easy. Do you remember when we started this chapter and we looked at the equation, the general formula for a parabola looks something like this? And then sometimes they put this other stuff on the end, but really the other stuff on the end doesn't matter right now. You know how you can tell if it opens up or if it opens down just by looking at it? And it always had to do with this number right here, the letter A. Whatever the number is in front of the x squared, whatever the x squared is being multiplied by, it's also called the coefficient, right? The coefficient on the x squared term will tell you whether it has a minimum or a maximum, right? If the letter A is greater than 1. Greater than 0. If it's a positive number, it's going to open up. And if it opens up, it's going to have a minimum, like this, right? However, if the letter A is less than 0, it's a negative, right? If it's a negative, your parabola is going to open down, and in that case, it's going to have a maximum like that graph right there. So that's how you can tell. All you need to do is look at the coefficient on the squared term, the x squared term. So for example, on these problems, all you're needing to look at on these three problems is right here, and right here, right? You see how all of those have a positive number that the x squared is being multiplied by, right? The coefficient on the x squared term is positive. positive 2. Here I had to write it in there as positive 1, and here's positive 1/3. If it's positive, you know that all of these graphs are going to open up, and if they open up, they have a bottom low point right here called the minimum. So these three would all have a minimum, all three of those. And then my three below this, see how all these have a negative coefficient on the x squared. Here we have negative 4x squared. The second one has negative 2/3 x squared. This one has just negative, which is really negative 1, right? Negative 1x squared. And so if it has a negative term for the x squared, you know that the graph is going to point down. It's going to open down. And if it opens down, it has a maximum value, right? It'll only have one or the other. You cannot have both. You will never see a graph of a parabola that has both a minimum and a maximum, at least on a parabola. So that's our basic introduction today. That's how you can tell just by looking at it, does it have a minimum or does it have a maximum? Just look for the x squared term, find the coefficient, find the number. What is the x squared being multiplied by? If it's a positive number, it's going to open up. It's going to have a minimum like these. If it has a negative number, it's going to open down, and when it opens down, it has a maximum, a high point, like those. All right, that's board number 1. Now, what will happen is the questions will eventually ask you, okay, does it have a minimum or maximum? Easy, we just talked about that. Then find it. What is the numerical value? What number is the minimum or maximum? Okay, don't panic about this. We did it yesterday. Step 1 should be easy. We just talked about it. Does this have a minimum or a maximum? All right, let's look at letter A. The only thing I need to look at to find out if it has minimum or maximum is remember this, your letter A, your letter B, your letter C. Look right here. My letter A is positive. It's positive 2. So if it's positive 2, what does that tell me? That tells me that this graph opens up, something like this. And if the graph opens up, it definitely has a point right down here. The vertex is called the minimum. This is the lowest point that the graph will ever reach. So this definitely has a minimum. That's the first part of my answer. I've satisfied the first statement here. Does this have a minimum or maximum? It has a minimum. Now find the minimum. What is the low point? What is the value right here? Remember what this was called, right? It's called the vertex. Do you remember how we found the vertex yesterday? There were 2 steps. It wasn't that difficult, I hope. Step 1, you had to find the axis of symmetry, didn't you? This is the formula, x equals negative b over 2a, to find the axis of symmetry. Now this is step 1. So I'm going to plug in negative b. Negative b, my b number right here is 12. So I'm going to do negative 12 over 2 times a. My a number is what I have in the blue box right there, 2. So I have negative 12 divided by 2 times 2. Okay, we know 2 times 2 is 4. So negative 12 divided by 4 is negative 3, right? And so my axis of symmetry is x equals negative 3. I'm just going to abbreviate here. That doesn't actually give me my answer because it didn't say what is the axis of symmetry. It said find the actual minimum, find the actual maximum. In this case, we're finding the minimum. How do we actually get the minimum amount? Remember what we did yesterday? After we found the axis of symmetry, do you remember what we did? We went back to the original problem. Here, let me just copy the original problem down again. I'm going to use black so it looks exactly like what I have over there. That 2 kind of doesn't look so strong. There we go. So I just copy the original problem down, and now I'm going to substitute negative 3 right here. I'm going to substitute negative 3 in the spot of the x. Both spots where I have an x, I'm going to put a negative 3 right there. All right, so I'm going to have 2 times, can we do this in our head, right? If we put negative 3 right here, negative 3 squared would be negative 3 times negative 3. That is 9. And then on the next one, you would have 12 times, here the x is again going to be negative 3. We're just going to substitute it in. 12 times negative 3. Some of you, I'm sure, can do that in your head, but I'm just going to go ahead and write it out. If you need to use a calculator for this, or if you can do it in your head, great. I think I can do it. 9 times 2, I hope, is 18. And then 12 times negative 3 is negative 36, and then plus 8. And now I can just do my order of operations, go from left to right. We have 18 plus negative 36, that's negative 18. Negative 18 plus 8 equals negative 10. And so my minimum value is right here. This is the minimum value, negative 10. The min value is negative 10, right? Remember how we wrote it yesterday? Yesterday we combined it and we said the vertex, if we wanted to be really cool, we could say the vertex is negative 3, negative 10. So really the minimum is just this part of your answer from yesterday, right? The minimum, negative 10, that's the lowest point that this graph reached right here, was 10 places below the origin. All right, and that's it. So this would be my official answer. I know I have boxes around everything, but my official answer would be right here. The minimum value is negative 10, and then it did have a minimum. Those would be my two answers. And that's all we have to do today. It's just using the same skills that we did yesterday. All right, let me try letter B. I'm going to erase this the best of my ability without smearing the board. Sometimes when I erase it, it leaves kind of a mess, but that looks pretty good. Okay, letter B. This one is a little different just because it starts with a negative, right? You can see right here my letter A value is going to be negative 3. My B value right there is going to be negative 24. My C value, which we still aren't using, it hasn't come into play yet into any of these questions, but it would have been 10, even though we aren't going to use it. Now, what do I know about this? I know that right here, my letter A is negative. If my letter A is negative, that tells me that this opens down. And if a parabola opens down, back up my camera a little bit. If a parabola opens down, it has this point up at the top, which is the definite high point that it ever reaches. The high point is going to be called the maximum. So, does this have a minimum or maximum? This graph definitely has a maximum. That's the first part of my answer. Now, how high is this? How high is this maximum point? Well, I don't know. That's where my numbers come in. I just can't guess. I've got to use the things that we just did on the last equation. We've got to do step 1, find the axis of symmetry. X equals negative b over 2a. All right, let's plug those numbers in. Negative b, negative, okay, where's b? B is negative 24. Uh-oh, I have negative 24. Does that really make sense? Negative 24, right? See how this has a negative and then this also had a negative? Negative and negative. Two negatives just make a positive, so you can just erase that or you can make it a plus sign. Sometimes people do this. They take the two negatives and they just make it a big plus sign if you would rather do that. And then on the bottom, 2 times a, my a value is right here, negative 3. So this is going to be what? 24, positive 24. 2 times negative 3, that's negative 6. Okay, 24 divided by negative 6, I think that's negative 4. So my axis of symmetry, even though it's not really part of this answer, my axis of symmetry is right here, x equals negative 4. Now that is helpful. It's not part of my answer, but it does help me because now it helps me use the original statement. Let me go ahead and write down this problem again since I scribbled all over it, put all those boxes. Maybe kind of hard to visualize. Here's what it originally said before I scribbled all over it. There was the original problem. Now all I need to do is take my axis of symmetry amount, negative 4, and plug it in right here and right here for the letter x. So I'm going to do, let's see, if I put negative 4 right here, I'm putting negative 4 from this answer in right here, negative 4 squared. That's negative 4 times negative 4. That's positive 16. Oh boy, this is going to be minus 24 times x. X is right here, negative 4. And then plus 10. Might need a calculator to help you on this. It's getting a little bit more up there in terms of numbers. 16 times negative 3, I believe, is negative 48. This is a little bit awkward because we have a negative sign or subtracting sign, and then this is going to be negative. I think this is negative 96. And then we have plus 10. So this really bothers me when we have minus. Go once again, just like up here when we had negative and negative, you can make negative and negative into a positive. So that's really just like one big plus sign. So we have negative 48 plus 96. I believe that is 48. 48 plus 10 equals 58. So there it is. My maximum value is 58. Or another way to write it if I really needed to. I don't know if the question would ask, but if the question ever asked you, hey guys, what is the vertex? The vertex would be our first answer, -4, and then our second answer, 58. All right, yesterday we wrote it like this, and we said, okay, this is the vertex, and then this is the axis of symmetry. I'm just going to stop right there. I ran out of room. This is how we had to write the answers yesterday, these two. Today they're going to want the answers like this and like this. It has a maximum, and the maximum value was 58. And there it is. So really, that is just a continuation of what we did yesterday. And that's about as tough as it gets today. Now, our book is going to try to go a little bit above and beyond and give you a couple word problems to see if you can apply this in more of a real-life setting. So I have 2 word problems. I modeled these after some of the word problems in our book. So if they're in the assignment today, this will be a great way to kind of see how to do them. Here's the first situation. A firework is shot from the ground. So you've got the little person here shooting off the fireworks. It's modeled by this function. So here's our equation. Notice it doesn't have a part at the end. It doesn't have a plus c because it's going to be shot from the ground, right? Remember, this letter c is always the y-intercept, and there is no like plus something or minus something at the end, a regular number, because this is shot from ground level. So it's technically 0. H stands for height, T stands for time. You can see this is T now instead of the letter X. Don't let that bother you. The firework explodes at its, sorry, it kind of got smeared off there, at its highest point. So we're going to shoot this firework off. Boom, 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 boom. It's going to go up in the air and then poof, sound effects, right? It's going to explode. So what we need to know is, when does it explode? When? That's a measurement of time, isn't it? That's why this has the letter T in it. And then, at what height does it explode? How high is this firework off the ground when it explodes? Isn't this the same thing as asking us, hey guys, isn't this eventually going to it's going to explode right here, and then technically some of the pieces would fall back to the ground, right? Isn't this a parabola? When you shoot something off the ground, it explodes at its highest point. There's your firework exploding, and then the pieces slowly fall back down to the ground. Right? This is a parabola. And if it breaks the question down into these 2 parts, when does it explode? That is the same thing as, what's the axis of symmetry, right? Solve this, -b over 2a, right? How many seconds does it take, right? How many seconds does it take imagine this is like your timeline. This is your x-axis. This is your x-axis right here. How many seconds does it take for this thing to eventually explode? So we're going to do the axis of symmetry when it asks you, how long does it take to explode? Or it asks for a measurement of time, right? So here we go. We're going to do -b over 2a. This -16 is the a. This is the b. There is no c. The c is technically 0 if you really wanted to know, but we don't have it in the formula, so it's not a big deal. -b is this amount right here, -176, divided by 2 times a. A is right here. A is the -16. Okay, so I have -176 divided by 2 times -16 is -32. I'm going to use my calculator for this because this is a little bit tougher. So here's my calculator. I'm going to do -176 divided by -32. Hope you can see that. Yeah, there we go. Answer 5.5. Okay. So it explodes in 5.5 seconds. Right? So after the fire department or whoever's shooting the fireworks off, after they light the fuse and the fuse ignites, it takes 5 seconds for the firework to travel up in the air, and then it explodes. And then part 2, at what height does it explode? Okay, that's basically asking you, hey, how high up are you? So we know we've traveled right here to 5.5 seconds, but now how high is it, right? What's the actual height of this? Okay, this is exactly what we did on the last question. When it wants to know the height, or the lowest point, if this thing was going the other way, it's asking you to plug this amount in to find the maximum, right? This is the maximum height. So how do I find the maximum? You just take this axis of symmetry number and you plug it in to the original problem. Now this is going to be a little bit complicated. Let me write the equation down again. Because these numbers are rather large, So we're going to have negative 16 times t squared. Now my t is right there. It's 5.5. So I'm going to need to use my calculator. I don't know 5.5 times 5.5. It's right here. 30.25. This is where definitely having a calculator is handy. And actually, if you have one of the fancy graphing calculators, I don't know how to do this because I don't have one, but the fancy graphing calculators can do this all on their own. You don't even have to type all this in. They just know how to do it. There's like a button to hit maximum or minimum. Anyway, and then we're going to do 176 times t, and t is 5.5. Okay, so I'm running out of space there. So this says negative 16 times 30.25. So I'm going to do 30.25 times negative 16. That's negative 484. And then in the second one, I have 176 times 5.5. And that is 968. And so now I have, to finish it off, I'm going to do negative 484 plus 968, and you get 484. So this explodes at 484. I should have told you in the question. The question will usually tell you what it's measured in. I didn't write it up here because I made a mistake, but I'm going to assume that it was feet. There it is. It's the same thing that we did on this question right here, right? Step 1, axis of symmetry. Step 2, plug it in, work it out. They just worded it into a real life situation, but it's the same thing. Step 1, axis of symmetry. Step 2, plug it in, work it out. Boom. There you go. So that's how it would work on our firework example. One last one, and then I'm done. I'm kind of proud of my artwork on this one. I'm not a very good artist, but my bridge here kind of looks at least somewhat like a bridge, maybe. Okay, now I've got a graph that opens down, right? A cable between the towers of a bridge is modeled by this. Y equals negative 0.04x squared minus 16x plus 100. X and Y are in feet. Oh, I actually put it on this one. Okay, so here's our bridge, right? Here's our parabola. See how this makes a parabola right here? The cable that comes down and forms the suspension bridge. So it's going to ask you how far from the tower is the lowest point, right? So these are the towers right here, right here. These are the towers. And it's asking you how far from that is the lowest point. How far is it from there to here? All right, this is the lowest point is also called the minimum, right? How long does it take for this thing to hit its lowest point? This is the opposite of the last question, right? Instead of the fireworks shooting up into the air, now I have this cable going down, but this is still going to be the axis of symmetry. So when it asks for a distance or an amount of time, how far along the x-axis here, we're going to do the axis of symmetry. Okay, here's your letter A, 0.04. Here's our letter B, negative 16. Here's our letter C, which we really don't need in this question. So we have A, B, and C. So we have negative B, negative 16, right? See how my equation has a negative and then this had a negative? So negative and negative, you know what? Let's just make that a positive. And then 2 times A, 2 times 0.04. All right, might need my calculator for this one. 2 times 0.04, I believe, is 0.08. But just to double check, let me clear out what I had. 2 times 0.04. Okay, whoa. There it is. It's 0.08. So we're going to do 16 divided by 0.08, and we get 200. Holy cow. All right, how far from the tower is its lowest point? 200 feet. So it's taken 200 feet to go from here to here. This is 200 feet, right? Now, if I was being really tricky, I could ask you how far is it between towers, all right? You see how this is halfway? If this is 200 feet, wouldn't this other half, right? The half where it goes uphill, this amount right here would also be 200 feet. So if I was being really mean, I could say, hey, how far is it between towers? It would be 200 and 200. 400 feet is all the way across this bridge, right? All the way across from there to there would be 400 feet. But that's not what it asked. I was just throwing that in there because sometimes books will be very tricky and they'll even put that question in there. Okay, what we need to do is, how high is the road above the water? Okay, that's basically asking you, imagine if we have water here, our water's going to be orange. What happened? Why do you have orange water? Oh, we got orange water down here. Nuclear power plant. had an accident. How high is this above the water? That's asking you for what is the minimum value. So we're going to take our 200, we're going to go back to the original statement, and we're going to plug 200 into the original problem. Whoa, lost my marker. So I'm going to go back to the original problem, y equals, and I'm going to do 0.04 times 200 squared. 200 squared. 200 times 200, in case you are needing a little bit of assistance on that, you could use a calculator. You could hit the squared button. You could also type in 200 times 200, 40,000. Wow. 0.04 times 40,000 minus, and then I have 16x right up here. 16 times x. Remember, x is this amount, 200. And then plus 100. So I'm just going to work this out. I'm going to need a calculator for this. 0.04 times 40,000. Okay, 0.04 times 40,000. That equals 1,600. You can see it right here. 16 times 200 has got to be 3,200, just in case you don't believe me or I don't believe myself. And there it is, 3,200 plus 100, and then I can just work this out. I can almost type this whole thing in my calculator, 1,600 times 3,200 plus 100. Oh, geez, I made a mistake. Okay, well, I screwed it up. I apologize, guys. This wouldn't make sense. How could your tower be negative 1,500 feet above the ground? My tower hits the water. Okay. Well, you can see why now I'm not a professional question writer, because that totally didn't make sense. So I apologize about that. But that is how you would do it. Normally in a real question that an actual textbook writer writes, it doesn't end up to be a negative because my bridge goes down into the water, and that is obviously not good. The domain and range. If we did want to describe the domain and range, remember the domain talks about how far this graph goes to the right and to the left. And these always go forever and ever to the right and forever and ever to the left. Oops, sorry about that. So our domain is going to be all real numbers, because this graph goes to infinity and beyond to the right and to infinity and beyond to the left. All real numbers. And our second answer for the range, the range is where it is on the y-axis. Now mine, because I messed it up, mine hit a low point right here of negative 1,500 feet. And so on mine, it would be my graph would be everything above negative 1,500 feet, greater than or equal to negative 1,500. In real life, you aren't going to have a bridge that's negative 1,500 feet. But mine turned out to be that way because I messed up my question. So there it is, guys. Hopefully you won't get a negative amount on yours if you do it like one of them in our textbook. So I hope this works out for you guys. Feel free to watch this video as you do the questions. I'm going to try to put some of these questions on our Big Ideas Math website. Some of them will be like the first one, where you just have to find the minimum and find the maximum. And then I'll try to pick some word problems like this, where you can try to do some of these tougher ones and do the same thing, but just in a different format as a word problem. So thank you so much for watching, and I'll catch you guys tomorrow. See ya.